76. 76 is y equals arc cosine or cosine inverse, the same thing, of sine inverse of t. Perfect. Very good pick. Okay. Please do not treat the power as being power. It's not a power. So if you want to, we can always do this. Arc cosine. So there is no confusion. This is arc sine t. Where's my calculator? Oh, I have it ready for you. Let me share my screen for a second. So here they are. See them in blue? I'm not sure if it's too small, but I'm sure you have your own calculators right here. This is sine inverse, so it's activated with the blue key. It doesn't mean sine to -1. It does not mean 1 over sine. It's the inverse function of this. So this is arc cosine, which is the inverse of function cosine, and arctan. That's why you see those here. These are the most important ones. That's why you don't see cotangent, secant, cosecant. Okay, so now we know where they are. So this is a more convenient notation, I think, because it's not confusing for some students. And also when I type, for me it's easier to type than put the power. So when I type, I prefer this notation. But it doesn't matter. You choose the one you like. Really, it's not important. So I have arc cosine of a function. So arc cosine of a function prime is -1 over the square root of 1 minus the function squared times the function prime. Because if this is a function and this is a function, then I always have to multiply by f prime, like we did with exponentials, like we did with sine, everything else. Okay, so arc cosine prime. So y prime equals -1 over the square root of 1 minus whatever times that whatever prime. And now I'm ready to look in. Okay, arc sine t. Arc sine t. Now I have to go back to the formula, and this is just simple. Arc sine t or arc sine x prime is 1 over the square root of 1 minus t squared. So I will write again and write negative the square root of 1 minus arc sine t times 1 over the square root of 1 minus t squared. No one can simplify this. This is it. So in this new book, they moved my trig functions, the inverse trig functions, in 3.6. Which is fine. Good. So let's take a look and analyze another. Oh, I didn't mean that. I didn't mean that. I meant this. And then we'll talk about logarithmic functions. There is a derivatives assessment, not in WebAssign, but only on paper, but after we finish this section and section 3.11.
72.
And it's, which one? 72. Very good.
72.
Got it. 72. I'm just going to copy it. So y equals arc tangent of x minus the square root of 1 plus x squared. Perfect pick. Thank you. Let's take a look. So I have to differentiate arctangent. And I know that this is 1, a very nice function. Very important. That's why from the very beginning we graphed this function, if you remember. And we used it in limits a lot. So it's 1 plus whatever squared times the whatever prime. So arctangent of a function prime is 1 over 1 plus that function squared times the function prime. Now I'm going to see what's in there. Oh, okay. So x minus the square root of 1 plus x squared and x minus the square root of 1 plus x squared. I continue. This I copy. And now I have to differentiate this. X prime. Anyone?
1.
Good. Minus the square root of a function prime. What do I write?
So 1 over 2 times the square root
Of whatever times
whatever.
that whatever prime. That's it. Now I'm going to uncover 1 plus x squared, 1 plus x squared. And what do I need instead of this? What do I need to write instead of this?
2x.
That's it. That will be replaced by 2x. So 1 over 1 plus x minus the square root of 1 plus x squared squared times 1 minus 2x at the top and 2 in the denominator. So these two will go away. I can simplify factors. And let's see if I can do anything here. So I have 1 over 1 plus x minus the square root of 1 plus x squared squared. Who knows how this, this may be, we may be able to simplify. Here the square root of 1 plus x squared. So minus, no, I'm sorry, it's multiplication. So it's the square root of 1 plus x squared minus x from this over the square root of 1 plus x squared. Don't try to simplify. We have to square this, add 1, and see what's happening, but I'm fine so far for this. So it's possible that when I square this, just give me 1 second, 1 plus x squared minus 2, the square root of 1 plus x squared plus 1 plus x squared. So then we have 2 plus 2x squared minus 2, the square root of 1 plus x squared, and I'll have 1 plus x squared minus the square root of 1 plus x squared. Who knows? Maybe if I rationalize and so on and so forth, I'm okay with this. It may be eventually some simplification possible, but it's good enough. I'm getting, you know, I meant to write 2 here, of course. So, and if we rationalize that, potentially, what do I get? And maybe when I distribute this, something happens here also. Who knows? I have to work much more on that. I'm okay with it. Okay. Anything else? Do we get the idea how to apply, how to differentiate arctangent, arccotangent, and arcsine? Arcsine, arccosine, and arccotangent. Do we understand how to do this? Do you think we need more examples?
Can we do a little more?
Yes, I'm ready. Any preference?
Scroll down a little.
Yes, of course.
278.
78. So here we have y equals arctangent of the square root of 1 minus x over 1 plus x. Perfect. Okay, so my props. I have to differentiate arctangent. What do I have to write?
1 for 1 minus
Plus 1 plus. Arctangent is the only one with plus. Over whatever squared times whatever prime. And now let's see. Ugly. 1 minus x over 1 plus x, square root of 1 minus x over 1 plus x. When I square a square root under certain conditions, right, but they have to be, this quantity has to be positive, otherwise we cannot take the square root, right? So when I square this, what do I get? I get 1 over 1 plus 1 minus x over 1 plus x. Do we agree with that step? Okay, times. Now I'm differentiating the square root. How do I differentiate the square root again?
1
Yes?
over 2 times square root of the function.
Square root of that, yes, I completely agree, times that function prime.
Derivative of that function.
Yep, so now I copy it. 1 minus x, 1 plus x, 1 minus x, 1 plus x. I'm one step closer. Here, I will multiply by 1 plus x, find the least common denominator, which is 1 plus x. And then I have 1 plus x plus 1 minus x. 1 plus x plus 1 minus x. So this is slightly more simplified. Here I'm going to flip. So times 1 over 2 and the square root of 1 plus x over 1 minus x, because it's a fraction. But here I have to use the quotient rule. Good. How do I use the quotient rule on 1 minus x over 1 plus x? How do I start?
Say minus 1.
Yes, negative 1 times the denominator. Very good. Minus the numerator, but it has to be in parentheses so I don't forget. Very good. Times the denominator prime, which is 1. Good. Great job. Okay. I flip. So it's 1 plus x over 2 times 1/2 times the square root 1 plus x over 1 minus x. And I would factor out negative 1 and put it in front right here. So now I have 1 plus x plus 1 minus x. So it's 2 over 1 plus x squared. This will simplify with this. This will simplify with one of these. And I have negative 1/2. Maybe I should put this in the denominator. And the square root of 1 plus x over the square root of 1 minus... Oh! I wanted to simplify, but it's better not to put it in two different radicals. So this is
Where
good.
did the first one become negative at?
I'm sorry?
Where did the 1 plus x over 2 become negative? From there? Okay.
No, it didn't. It's the whole thing is negative, not that. So the negative, I
Okay.
factor out negative 1 and I put it in front. So then I have 1 plus x plus 1 minus x. The two x's go away and I have a 2.
Okay.
If one of the factors is negative, then the whole product is negative.
I was just trying to figure out where the negative was.
Yeah. It was coming from here.
Okay.
And this is final. Not a nice function. Good pick. Just to make sure. Very good pick. Two types of functions we still have to talk about. Log and hyperbolic. And this will be the end of the different functions that we have to talk about. Of course, any base. and we're going to start with natural log. Now, please tell me if we need more examples of inverse trig, or did we get the idea on how to differentiate inverse trig? Any more examples for inverse trig functions? We cannot do these just yet. In a minute, we will. Okay, so let's talk about the natural log and the hyperbolic functions. Now, hyperbolic functions, I just want to make sure. So this is still in 3.5, but these will be in 3.11. I'm not skipping anything in between. There is only one section that we don't cover, which was covered in pre-calculus. But we want to have all functions ready for the derivatives assessment that we have to turn in sometime next week. I have to look. So let's finish up the log, and then we look at the hyperbolic. Hopefully we have time to finish that today. We'll see. So these are basically different functions that we want to learn how to differentiate. That's all it means. So when we differentiate natural log, we simply get 1 over x. What if I have natural log of a function? Can anyone give it a shot? Just based on what we looked at so far. What do you think this will equal to?
One over the function. 1 over f?
1 over f times
F. Or 1. The function.
Exactly. This is what we all had all the time, right? E to a function prime, we said e to the function times the function prime, right? A function to a power prime, n, f to n minus 1 times the function prime. Everything ends with a function prime, if it's a function. If it's just plain x, it ends with x prime, but there is no need, because it's 1. Also, we can prove this, that natural log of the absolute value prime is only 1 over x as well. We can prove this, and let's do it just quickly. The absolute value of x, as we know, we've discussed this a long time ago, greater than or equal to 0 or negative x for less than 0. But when we apply it to natural log of x, to natural log, I cannot have 0 in natural log. Don't erase it. I'm just making a point. So this could be only natural log x for x greater than 0, or natural log of negative x for x less than 0. So when we differentiate natural log of the absolute value of x, we get 1 over x for x greater than 0. And we get, this is natural log of a function, 1 over negative x times the inner function prime. And this will cancel out. And still get 1 over x. So if it's greater than 0 or less than 0, we still get the same answer, because this will give us 1 over x. Now, this is very important. This is very important for chapter 5. Not this immediate situation, if you want. But for chapter 5 is extremely important. I'm going to come back to that. Okay. So let's take a look at a few examples, and then we're going to look at the example in which the base is not e, but anything else.